So we have the log files over here in our S3 bucket. This is an example log file with 10,000 to 15,000 records in each log files. But in practical cases, we will have thousands and thousands of lines of logs, and we might even have terabytes worth of the log files over here. So in order to process that, if we need to do some operations on the log files, it will take a lot of time to parse through the entire log file, to read through the log files and search for a specific pattern or search for log files within a specific time range. To make it efficient, we have to come up with a creative solutions to approach this problem. So that we have to index it fast, so that we have to access the log file faster for each Lambda functions, because Lambda functions are the cost of the Lambda functions are calculated based on the time that they execute and the memory that they use. So we need to be conscious of those things also when making the decisions. So we have this workflow here. We have an EC2 machine that is generating the log files, and that is being transferred to the S3 bucket. So we set up a trigger whenever there is a file added to our S3 bucket. It triggers another Lambda, and that Lambda function will take this log file and create an index of these log files based on the timestamps. It will index the timestamp, and it will also note down which file has this timestamp of data and what is the starting byte position within that file and also the ending byte position within that file. So if we are supposed to search for a specific timestamp, we can just load this index, see where this timestamp is. We'll get the specific start byte index and also the file name. We just have to load that file and we have to load that part. This essentially saves us a lot of time. We don't have to download the data to the memory. We don't have to read all the data from the files. And it is also a very faster access because the index is stored in a hash set, in a key value pairs. So it is basically O of 1. The search time is O of 1. So we can see over here, so we have this hash processor Lambda function. The trigger has been set to the S3. Whenever we add a file to our logs directory in our S3 bucket with a suffix .log, this Lambda function gets triggered. This Lambda function reads the log files part by part. After reading it, it creates the index and it stores it as a hash table, as a pickle file over here. So we can see the size of the pickle files. So it is just 260 bytes, and we have like 5.9 and 5.8 KB bytes. This is several magnitudes lesser than the actual log files that we have here. We have 1.7 MB of data over here, and we just have 5 KB of data in our pickle file, in the index file. So the amount of memory that we need to load it is also low, and we can go and read only those specific buckets or blocks of data within this file. This helps skip a lot of overhead in terms of log processing and log management. The other Lambda functions, we'll have a look at the other Lambda functions. First is the log query Lambda function. We might not be able to see the code here because it has the dependency packages and we have uploaded it in a zip file. So this is too large, but we can see how it is implemented in our REST framework, in the REST in the Lambda that was designed for the REST. So we basically load the pickle path, we assign the constants, and first step what we do is we check if the particular date exists in the log files. Our log files, we have a pattern in our log files which is named by the date. If there is no date available, if there is no log available for the date, we return a 404 response saying that we don't have logs for the specific date. And the same way, if we have the date files for the date, then we check for the timestamp. How do we do that? We load the index for that specific date. We have seen that in the pickle file, the output produced by the hash processor Lambda. After loading that file, what we do is we check for that specific timestamp that we are interested in, And if it is not there, we again send a 404 request. If we find that if we then find if we have the data again, then we go ahead and process our logic. So this is how it basically works. The same, this is how the Lambda over here works. This is a Lambda file for the REST, but it also represents the logic for the gRPC. The Lambda is triggered from an API gateway. We get the Lambda is invoked. Then we get the parse the data. We convert the gRPC and we convert the encoded gRPC, marshal gRPC, and we extract data from them, do an index lookup, and request for the file from our log processor, and then process and send back the output. This is how the 3 Lambda functions work. One Lambda function for the hash processing, the indexing. The second Lambda function is for the log query REST framework, to handle the REST framework, to handle get and post methods. The third one is to handle it for the gRPC based requests, HTTP calls. Thank you.